Okay, what I want to talk about today is the what are called the wrapper classes, the integer class and the double class. And if there's time, we'll talk about it a little bit more. But these are called wrapper classes. It's integer, capital I, spelled out completely, and double, with a capital D, spelled out completely. They're called the wrapper classes because they are a class that contain only one instance variable, and that instance variable is of whatever type this is representing. Okay? So if you were to say integer x equals 42, then x is an integer reference that points to a space in memory, and in that space in memory, it is a class, or an object rather, but it contains the value of 42. And in fact, I think the actual, the name of that instance variable is called int value. Okay? So let me show you how to implement this in code, as well as some pretty cool things that Java does to make your life even easier. Integer x equals new integer 42. And then system.out.println x dot int value. So you can see here we are using the constructor, and we're sending it an initial value of 42, and that's putting it inside the int value instance variable. And then whenever we need to pull that out, we access the int value method, which will return. So actually, I don't know if I said this is called int value. I don't know what that really is called on the inside there. It might be private. Let's see if we can figure out x dot. I'm looking at a whole bunch of methods. Some static final, a bunch of static methods. Oh wow, there's a bunch of stuff going on here. So actually, I said it was called int value. I really don't know what it's called. They probably have that as private, so you can't go in there and mess with it. So this is, I guess in this case, a really good example of object-oriented programming, because we don't really know what's inside there, but we do have a way of accessing it in other terms of read-only value, in terms of getting it right there, getting the value of it via this public method. Make sense? Everything's great? Okay, well, let me show you some really neat things that when they made Java, anyway, I think 7 or 8 or something like that, they made some pretty cool changes. Maybe it was in Java 5. They said, you know what? That's a little bit too burdensome. Okay, having to create a new class with 42 in there. Let's make things easier for our programmer friends, and let's just do this. Integer x equals 42. You'll notice it compiles and runs exactly the same. And you might say, okay, that's pretty neat. And I'd say, yeah, it's actually very neat, because you can't do that with any other object. Okay? Any other object, like for instance our dog class, we said dog DG equals new dog, you know? And you would actually have to say, you know, Fido, and then give it an age, something like that. You know what I mean? You have to have that new keyword to instantiate, to actually go out into memory and to carve that space. However, with the wrapper class, the integer, and the double for that matter, Java provides a way, it's called auto boxing. Okay? It automatically constructs the wrapper, okay, around it, the box around it, and puts the value in. Okay? And you don't have to use that new keyword. And you might say, well, that's great. What about unboxing? Do they do that? And the answer is, yep. You can just say that. System.println x. And what it does is it calls the toString method, which then the toString method calls the int value method. Okay? Now, this is where things get interesting. I'm going to say int y equals 10. And then int z equals, now think of this if I had to do this the long way, auto boxing, unboxing, okay. Y plus x dot int value. I'd have to do that if I wanted to actually get the value of it, right? Well, no need for it. I can just say y plus x.
I found how to, what's the name of the variable?
What is it?
Value.
Value. Dot value. Is it public or private?
It's private final int value.
Okay. So you might say, okay, no big deal. It's just doing y plus x, 42 plus 10. Yeah, that would make sense if they were both ints, primitive, okay? But think about what we're combining here. We're combining a primitive with an object. It would make the most sense of saying y plus dog or y plus dg1. How the heck? Java's like, I don't know how to add that. What does that mean? Well, with the exception, it doesn't know what that means. With the exception of the integer class and the double class, it knows when it sees that plus and one of these values is a wrapper class, it knows to unbox it, so unpackage it, and get just the regular integer value of the 42, then add it to the 10, and then we could print that out if we wanted to. And you've got there 52. The same thing works with the double class. Double PI equals 3.14. And then I can say double pi2 equals 2 times pi. Are we recording?
Mm-hmm.
Okay. System.println pi2. Sure?
Mm-hmm.
Okay, great. And so Java will do the boxing, the unboxing, all of that stuff. Boxing, unboxing, boxing, unboxing. And for the most part, it's very fast, it's very effective, and it makes your programming life a lot easier. So that might make you ask the question, well, why do we deal with these things, right? Why not just use an int? The short answer is, wait a couple weeks. There's some things that you have to use with classes that you can't do with primitives. We dealt with this a little bit last year. If you remember the array list, array lists have to have classes. They can't have primitives. So if you have an array list of a certain type, it has to be of type integer or of type double or a custom class that you made. You cannot have an array list of ints or of doubles with a lowercase d. It has to be of classes. And so the way around that is they said, okay, let's make a class which simply contains that basic value. And that would be fine. Problem, or I don't know if it's a problem, but as an added bonus thing, they said, and while we're there, let's go ahead and add a bunch of other tools inside that integer class. For instance, let's provide inside that integer class a record of the maximum integer value that you can have, as well as the minimum integer value that you can have. We want to provide that information somewhere to programmers. Well, it seems to us that makes the most sense that you put it inside the integer class. Have we talked about it during this with the school year? Max value and min value? Maybe, maybe not. I know I talked to my AP students, but if you remember, you can say system.out.println if you want to know what is the biggest integer that you could possibly, that is the biggest int that you could have. That information is stored in the integer class dot max underscore value. You could use caps lock. If you want to know the smallest value that you can store in integer, you can say integer dot min value. So they provided a place to store that. Now, you're like, okay, that doesn't seem like a big deal. So what? Well, those are static variables, so they don't take up a whole lot of extra space. If actually don't really take up any extra space in memory. But some of the other tools that they provided with the integer and the double, Rosa, just a little bit softer, please. They do provide a little bit of extra, I don't know how to put it, overhead. Okay, other functionality with these that does make them a little too bloated, so that when you're using them in high-speed operations, it can actually slow things down. Okay, when we get to more advanced data structures and stuff like that, that'll make a little more sense. But you can say, well, why don't we just make everything capital I integers and everything double with a capital D? All right, because why do we even bother with int and double at all? And the short answer is because there is extra memory that's associated with these, and because of the extra memory, then there's also going to be a time delay. It's not a lot when you're dealing with, it's hardly anything, not even noticeable, small program like this, okay? But if you have a program that's processing tens of thousands or hundreds and thousands of millions of these operations, then that really adds up. And the primitives themselves, the int and the double, the lowercase d, are very, very high speed. They're written straight onto the memory or straight onto the, I don't want to say it. I don't know all the details, but it's almost like they're written straight onto like the cache, okay? The registers, they're very, very fast acting, and it's like they're hard coded in there. This has extra stuff with it. If you want to, you could also find the range for doubles. I think we utilized integer.maxValue and min value when we were trying to find the maximum or minimum of a list. See if that rings any bells. Mm-hmm. If there's normally, if you want to find the highest score in a list, you know that the user is about to send you a list of data. You set the high score as its initial value to the lowest possible value. That way, no matter what the first value that they tell you, if you compare it with the high score, that current value is going to be equal or higher to that initial value. And then you just keep going through that way. An alternate way of finding the maximum is to set the first value equal to the high score, and then to continue on through. But I feel like this is a much more elegant solution. We talked about that last year. Okay, so what is the maximum value that we can have for a double? Oh, okay. 1.797 blah blah blah. Do you see the E?
Mm-hmm.
Oh, that's why it was smaller.
And I'm like, well, not 1.7, that's not very big. Yeah, well, times 10 to the 308.
Yeah.
So, and there's some added stuff there. It's called a floating point value because that decimal can float anywhere in there. And the more precision, the more bits that you're using for this, then the less bits that you have for that. So, anyway, a little bit of a trade-off. Does anybody remember some of the primitive types other than int and double?
Car or char.
Mm-hmm. There was char. That has a wrapper class called character. We'll talk about that next time. Anybody remember any other? What's that?
Boolean.
Boolean? I don't know if there's a Boolean wrapper class. Let's find out. Boolean. Can't be X. Yeah, that works. TF dot equals hash code toString compared to get class notify. It's got all that standard stuff. Type compare. Yeah, it's all there. Anybody else remember any other?
Long? Is it long?
Long, short, yeah. That's the longest integer value that you're going to have. In fact, in order of its byte, these are the integer types. There's byte, then there's short, then there's integer, and then there's long. Let's see how big a long is. System.out.println long.max value. In fact, let's put them in order. So a byte, the biggest value that you can get is 127. A short, the largest value you can have is 32,767. So about I just rounded to 30,000. An integer, I think that's 2 billion, is that right? That's what I always say. 1, 2, 3, 4,
Yeah.
5, 6. So that's,
Yeah. 2 billion.
yeah, 2 billion, 2.1 billion. And then look how big that long can be. So that's quite a few digits. I don't even know how many that is. I will tell you, we'll discuss a little bit later, but there is another class. Now this is in the library. It's not actually in the link. It's provided by Java, the Java people, but it's called big integer. Big integer bi equals new big integer. I don't know if that's even going to work. Let's say 5L. Will that work? Big integer cannot be resolved to a type. Import, oh, you have to import it from the java.math. You have to say import java.math.biginteger or java.math.star. Can we do that? trying to. I'm just trying to get it going here. Any luck? The literal is out of range. How about that? The constructor big integer long is not visible. Okay. Well, what constructors are visible? All right. Let's look up the. We're going to go on a little side quest here. Let's look up the Java documentation on big integer. Java big integer class. Here we go, big integer. Constructors. Oh, big integer string. Translates the decimal string representation of a big integer into a big. Well, that's even easier. I just need to put a string in there. Da, 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 da. That was easy. System.out.println. Tell you what, while we're looking here, let's go ahead and look and see. Is there a max value? Returns the maximum of this big integer in val. Power shift. I was just wondering if there's a max value equivalent. Divide. Vi dot. If I type in max, returns the maximum of this big integer in val. It's not going to actually tell us what the biggest one that it could possibly be. I don't know if there is a biggest value. Cody's got it. All right.
And it brought to the next line.
How big can Java big integer get? Come on, Stack Exchange. Ooh, what are the limits of string size in big integer? Big integer is around 2 to the 37th. If you're working with values this large, algorithmic time and space complexity is probably already rendered infeasible. It appears the string is limited by 2 to 31 minus 1 array elements or your available heap size. Okay. So 2 to the 30, now other people say there is no theoretical limit. Okay. So 2 to the 31st, that's pretty darn big. But I think that's the number of bits, so I'm not sure exactly. It's going to be pretty. Have you found a limit?
No. Scrapping to the next line.
Is this a deep enough rabbit trail? Okay, that's for our UIL computer science folks. Big integer occasionally has been helpful on programs, the programming portion. So, okay, that's enough about big integer. What else do let's looking here. We talked about the constructor in values equals. That works the same way. Two-string int I radix. We will talk about that a little bit later after we deal with number systems. Compared to and parse int. Of course, how could I forget? So, if for whatever reason you have a string which contains a number, you can convert that string into an integer or a double accordingly. I could say int num equals, I couldn't normally do this. Int num equals 56. Why not? Why not, Dylan?
Two quotes.
Yeah, 'cause it doesn't.
I want Dylan to tell me.
Does the quotes don't allow, no?
I mean, that line right there is giving me an error.
Oh, yeah, because it's quotes, right?
Yeah, it's a string. String can't be. However, I can convert that 56 into an int through a technique called parsing. And the integer class provides that capability. Integer.parseInt. And then inside you put a string. And then you can just print it out. No big deal. 56. The same thing works for double. You can do double.parseDouble. If you were in the UIL computer science meeting earlier today, you'll remember the reason why this is helpful is that if you want to use that next line to grab a line from the file, and then you want to convert it. The only problem you're ever going to run into is if it just so happens that there is not a legitimate number inside there. So for instance, if it's 56.8, you'll get a runtime error. Looks like number format exception.
So if it's a double, it would just run it just fine, correct?
That's correct.
So it doesn't even try to truncate it or nothing?
That is correct. I wonder, integer dot hashcode is, like, I wonder if there's a way that you could test to see if a variable did contain a legitimate number. Do you know what I'm saying? It looks, so that's why it's like has, but that's not the case. What if I say string s equals 56.8 s dot has, no. Well, anybody have any way of, I want to know, is that is this a legitimate number? You know what I mean? Like before I run this, I want to try it out. You know what I mean? I want to see, is what's inside that actually an integer, in which case this will work, or not? You know what I mean? So it looks like there isn't really a way that I can try it out with the parseInt. One thing that I could do is I could use Java's try and catch blocks. So watch this, I can say try that code right there. And it literally will try it. If there's an exception, then I can catch it. In fact, I'm going to catch a number format exception, and I'll call it NF. I think I don't need the parentheses. I think I can just say insert to complete the catches. Okay, let's try that. System.out.println, you should have entered an int. And so this is the way that Java uses exceptions. If I run this, there's an error somewhere. Num. Oh. You should have entered an int. Notice it ran the code, And what happened, you can't see it, but this actually threw that error, that number format exception that a minute ago was all red lines of death and crashed the program. The reason why it crashed the program is because this threw an error and it wasn't caught by anybody. So it ended up, it threw up that error, so to speak, and my program didn't catch it. So the program which was running my program caught it, the Java runtime engine, the thing that turns that byte code into computer code. That thing was running and it caught that error, and that's what spit out the red lines of death. With the try and catch block, I kind of get in between the Java runtime engine and my code, and I say, try this out. If it has any problems, then I catch it and process it, and that's what this is. Sometimes they throw a little bit of extra information, okay? And so what actually gets thrown isn't just an error message, but it actually throws an object, okay? And that object is of type number format exception. So they don't just throw a little string and piece of information, hey, we had a problem. They actually put that string along with anything else that's going on, and they wrap it inside what's called an exception object, and that's what they throw up. And then, so I say, all right, this is one I want to catch. And then if you want to, we could do all kinds of other stuff. I could say nf dot, and I could get the message. I could print that message out. So I could say system.out.println nf dot get message, and then I could say system.out.println the message showed, but the program kept running. You should have entered an int. This says for input string 56.8. So that's the that's the message. I wonder if there's anything else. nf dot, is there like a stack trace? Get stack trace. Print stack trace. I can cause red lines of death now, but my program still runs. Remember how I always say red lines of death, that's the stack trace, show you what the problems are? Okay, so when Java catches that little error, it not only has a little message, hey, there was a problem, and puts it inside that object, but it also wraps inside that object a stack trace, those red lines of death, that whole error message. And so then I can catch it, and I can look at it, I can process it however I want, if you really wanted to handle things. And that's, if you have some more complex code, you can actually have stuff that catches all of your exceptions and never kills the program. Really good, safe programming has lots and lots of try and catches surrounding entire bits so that your program itself never crashes. If it does cause some sort of exception, then it's handled accordingly by your program. That's something that we're really not going to get into a whole lot, but this is a third year of programming. I figure you guys need to know a little bit more about try and catch blocks, since I know you've seen them. Some cases you have to have them. Java says you better deal with this, that are like system critical things. Like if you open a file, you have to tell Java how you're going to process that. Either you process it yourself, or you say, somebody, I'm going to pass the bucket on up to somebody else. There's some things like this that Java's like, yeah, we'll handle it even if you don't. All right? So if you look here, this is kind of cool. You can still see, you should have entered an int for input string 56.8. You can see there it actually says the stack trace is, here's the exception, here's the message, which is that exact same message for string input 50. And then I printed the stack trace, but it didn't end the whole program, because any other time that you've had a runtime error and you've seen red lines of death, everything stopped, right? But now look at what's below there. The message showed, but the program kept running. So I can comment out that stack trace and run the program, and I don't get those red lines of death, which is super cool. All right. So sorry, we're chasing all kinds of rabbits here. Exceptions, try and catch, stack traces, big integer, but that's okay, because that's pretty much everything else I wanted to show you was about the integer and the double class as the wrapper boxing, unboxing. Any questions? Ivan, what about you? Any questions or anything?
I found that there's an atomic wrapper class.
Oh, what now?
Atomic?
Atomic.
Yeah.
What is it? Tell me about it now.
It just says with Java 5.0, additional wrapper classes were introduced in the java.util.concurrent.atomic package. These classes are mutable and cannot be used as a replacement for the regular wrapper classes. Instead, they provide atomic operations for addition, increment, and assignment.
Okay. Ouch. That's interesting. Jeremy, any questions? Nick? All right. Let's talk about a few more things. In a Google Classroom, I posted a link to the quiz folder. See if y'all can open that up. Because I thought this is going to be annoying just to create a different quiz assignment every time. I'll just give you guys access to the folder and then see if you can change the stuff. So see if you guys can access that folder.
Yeah.
And if you want to, you can then grab that folder. So go ahead and now click on one of the quizzes. Can you make changes to it?
Yeah.
Okay. Dylan, I didn't see you didn't have stuff in by Friday.
I did.
Well,
Yeah.
not by the end of, not by 3:30, which is what I think I put like an M for those assignments. But I know you went back and you were there
I
done
did
by the
on-
end of
I did them on Thursday.
Oh.
Thursday night.
They're not tagged with your name.
Oh.
With your initials. Tag them with your initials.
Yes, sir.
And that goes for everybody else. And you'll need to give me a note at some point. I need to cut those up. If you don't have an assignment finished, or for whatever reason, like there's miscommunication, not because you can put your initials on that. At the end of every week, I'm typing all the grades in, normally between 3:30 and 4.
Yes, sir.
And so for you, I put an M. I know you had it finished, but I wasn't sure which ones were yours.
Okay. Yeah, I'll put those in tonight.
So the thing is then, if you want me to go back and fix something, I need to have my grader cut these up. But it'll say missing homework or whatever, a little form, because then I'm gonna have to go back and update the grade book. And this will provide a document trail for me to make sure. Anyway, I'll have that and you can put it inside this little white box. I just don't have this copied off yet. So let's talk a little bit more about that A+ book, okay? I think by this Friday you need to have chapter 4 read, okay? When we get to chapter 12, which is building your own computer, we will go to Amazon as a group and have some fun, making a wish list. Newegg, is that the other place? Where else do y'all shop at?
I don't use Newegg for a reason, but.
Okay. Where else do y'all go?
Newegg does work, eBay.
Can you get stuff on Amazon?
Yeah, Amazon's probably the best place.
Amazon works with school purchases and stuff like that. And I'd like for us to, it'd be fine if I just went on there and looked, but that eliminates all the fun part of it. I want us to look, say, let's maybe make 2 or maybe 3 computers. I'm thinking, utilize what we know from the chapters about processors. Maybe we need to get, let's look and see what if we want to build a computer. Let's get an AMD computer and an Intel computer. And let's get a couple different types of RAM. And let's get maybe get a couple different hard drives. Eventually you're going to get to the chapter that's going to talk about partitioning hard drives and implementing hard drives, and we're going to go through that. But you need to read the book first so you kind of know what it's talking about. We'll have one of the computers, if possible, running Windows 7, one of them running Windows
Just
10, I guess, or whatever. What's that?
I can put whatever on it, you just tell me.
Yeah, we'll flash the BIOS, or however you say it. We'll we'll get a couple different. I'd like to get a couple different form factor motherboards. Just how much does it really cost?
Motherboards?
Yeah.
Anywhere right now, everything's so high because of Bitcoin. It's
Okay.
like 150 to 200 bucks right now.
Okay. Well, maybe we can find. Maybe you can bring some demos for us. So we'll need at least 2 motherboards, but it'd be nice to be able to see some of the other motherboards and stuff like that, just so we can get our hands on them and get that process going. So that's a whole lot of stuff that we'll be working on. But you need to be reading through that book, chapter 12. After that point, it really kind of stops talking about hardware and starts and deals more with the software. Okay, so that's going to be a good point for us to then start going and getting our hands dirty with things like that. So, plus we can start even now if you want to. If y'all want to start looking up some different things on Amazon, different RAM, different hard drives, things like that. Put a little wish list together, and then we'll pull it up and make some discussions in class about what we want to buy and what we want to order. Okay?
Recommendation, look
Sure.
for the CPU first, because CPUs are what's hard to find, and that will dictate what board you get.
Okay. So, and that's the kind of stuff we want to know. All right. See y'all tomorrow.